right, so what if, once it gets down here, it hits something? All right, swings, hits an object. Now the object, we're not going to actually plug into those formulas right now, but you tell me, what would be conserved in the moment of that collision? Are there any forces acting in the horizontal direction besides the contact forces between, say, the ball at the end of the string and the block that it hits? No, there's no other forces acting in that direction. So that would be an elastic collision. The x component of momentum would be conserved because there are no external forces acting in the x direction at that moment. So we could, in principle, if I were to, say, give you enough information to figure out from an elastic collision formula what the velocity of this thing was before the collision. Maybe I give you the velocity after collision. You can figure out the velocity before collision. And from the velocity before collision, you could find the angle that it started from using energy conservation, right? Okay, any other questions on that? Let's see if this works. All right, then here's a problem. Given that for a damped driven spring, amplitude of the oscillations is amplitude of the driving force over given that, and the tangent of delta, how did that happen? Tangent of delta is 2 beta omega over omega naught squared minus omega squared. What if I were to tell you that the driving force is F naught so much better than writing on a board. Let me tell you. What if I were to give you that, and I were to tell you that x of t was, let me make sure I get my minus signs correct. That where this is 2 pi over omega. All right, this is the steady state. It's got to go at the same frequency as the driving force in steady state. And I want to know the relationship between omega, omega naught, beta, i.e. write omega naught in terms of omega and beta. Give you that graph. You have to figure out what omega naught is. And note I haven't labeled the vertical scale, but I'm telling you that you don't need me to label the vertical scale.
medium. I tried doing this. Oh, I messed up.
Anybody have a question for me so far? Let me ask you this, if I've given you enough information to find A, or delta, or both, or neither? What? Delta, yeah, what's delta? 3 pi over 2, yeah. Yeah. Because this looks to me like minus sine of omega t. Right? So, if it's minus sine of omega t, then it's minus sine of omega t, then I think we know what delta's gotta be. It's gotta be pi over 2 or 3 pi over 2. What's the tangent of that? What? Yeah, tangent is effectively infinity. If the tangent is infinity, then what's this thing? 0. So, tell me what omega naught is in terms of omega and or beta. Yep, it's in resonance. That's all you needed to know. Questions? No, because in the steady state, omega is the frequency of the driving force. Omega naught is the natural frequency. So the fact that it's in the steady state means that we'll always be moving at the frequency of the driving force. The frequency of the driving force may or may not be equal to the natural frequency. Is there a question back?
How did you find a value for delta knowing the...
Well,